Hi, kids! All right, I want to go through some proportional reasoning stuff with you. Ball rolls down a ramp of length L, so if I was to show this to you, here is my ramp of length L, okay? It says, if the ramp was 3 times as long, what would happen to the time going down the ramp? What would happen to the final speed at the end? So let's go through this. I want to show you guys a different thought process other than the one that was on the other video, just so you guys have a different way that you can approach this, okay? So if we were doing this, if the time was twice as long. So if you think about this, if I wanted to approach this, I could say, hey, you know what? If I call this A, if I call this B, hopefully you can see that okay, that if I go from A to B, my initial velocity is 0, my displacement is this L, my A is going to be some number, okay, it's going to be constant, it's the same ramp, and let's see, I'm looking at time, so time equals question mark. All right, so let's take a look. Do I have an equation that relates all this stuff? I sure do, which is going to be x equals VOT plus 1/2 AT squared, and if you take a look, hopefully it makes sense that, hey, this whole piece goes away. Why? Because my initial velocity is 0. So I end up with x equals, I'll actually write it down. Okay, so, or if you want, L equals 1/2 AT squared. So let's do the problem that's here. It says, if the ramp was 3 times as long, what would happen? If you get to this point, guys, let's just plug stuff in. So like, right underneath here, this is times 3. So this is now going to be times 3 times as big, okay? This whole piece is staying the same. So then I have t squared. And if you want, if you're a math person, just say, hey, t equals the square root of 3. So what happens to the time? It's going to be square root of 3 times longer, okay? Hopefully that makes sense. If I am looking for the final velocity, then it's my, hey, v equals question mark. If you think about, hey, I want an equation that has this stuff in it, v squared equals vo squared plus 2ax, or in this case it would be L. If I look at this piece is going to go away, hopefully that makes sense. So I end up with, I'm just going to write it, v squared equals 2a times x. Well, I'm looking for what happens to this. This is the same. You guys with me there, okay? 2 times a is, nothing's happening if I make it 3 times long. Well, this is going to be times 3. So that means I get v squared, v squared equals times 3. So that means my v would be also times the square root of 3. Boom. Hopefully that makes sense. All right, let's try this other one. If the ramp was twice as steep, so the acceleration is 2 times as great, so I got a steeper ramp, what happens to blah, blah, blah. All right, so if we do our different givens here, okay, then this is now going to be like, hey, I know this is my A, and my A now is going to be times 2 or whatever, and I'm looking for my time, I'm looking for my final. All right, so again, kind of do the same thing. Do I have an equation that relates this stuff? I sure do. So x equals VOT plus 1/2 AT squared. Hopefully it makes sense. That goes away. X equals 1/2 AT squared. So if you look, okay, this is just a given. So like this stays the same. So who cares about the 1/2 piece? Okay, that's a given. If you want, I could just write equals. But this is, the ramp was twice as steep. So if you look, my A is going to be times 2. My ramp is the same ramp, so this is staying the same. And then I have t squared. So hey, what is going to happen to t squared so that this stays the same? Well, that would have to be times the square root of 2. Why? Because, nope. Not times the square root of 2, because if I took the square root of 2, that would be times 4. I would want to go 1 divided by the square root of 2 times bigger. Why? Because if I square that, I get a half. A half times 2 is 1, so I get the same length that what I get. So you can look at it this way, or if you like, this would be the same thing as times square root of 1/2. Okay. Final speed. Okay, so if I do my equation, so if I want an equation that has final speed in it, I'm going to go x equals v final t minus 1/2 at squared. Oh, my time's not constant, that's not going to work. So if I say v equals vo plus at, now that one's going to work. No, it won't because my time's not constant. All right, so let's try a different one. Final speed, acceleration. So I want a v. Here we go. This is the one I want. Sorry about that. All right, so this one doesn't have a t in it. All right, if you guys take a look, hopefully this makes sense. Goodbye. And if I just write my equation, v squared equals 2ax, okay? So that this whole piece is now going to be times 2. This whole piece is going to be times 2. This is staying the same. So then what happens to my v squared? So I get times 2. Well, that means I would have to be square root of 2. So that this equals this whole thing times 2. What do I get? Well, it had to be square root of 2. Hopefully that helps.
Bye, kids.